Greetings, this is Rick Powers, coming to you from my home office from Western Technical College, Introductory Statistics, using R for discrete probability distributions. I'm going to share my screen with you here so that you can see what I'm doing. So here we have a problem that's a discrete probability distribution. The number of pairs of dress shoes owned by men is a discrete random variable with the following probability distribution. What does that mean? It means that the number of pairs of dress shoes can be described by using a variable x. If it's 0, then these are people that have no dress shoes. 1 means they have 1 pair of dress shoes, and so on. And then the probability distribution means that we have different percentages. 65% of men have no dress shoes, so that's probability of 0.65, and so on. These are made up numbers. I'm not sure exactly where I would be put in here. I'm not sure how many of my shoes would count as being dress shoes, but anyway. So what we're going to do is we're going to take this problem and we're going to find out these numbers that are listed here using the program R. So we go to using R, discrete probability distributions, click on that, and it has the snippet website. Now I'm going to do Control-click, and it will open up the snippet website. Website looks like this. And so what we're going to do is we're going to look in this blue box that's right here, and we're going to take the code that's in the instruction, and we're going to put it in that blue box. So I go back to the instructions. I make a copy of, by just selecting it with my mouse here, I'm going to copy all of this information, Control-C. Then I'm going to go back here, and I'm going to take all this information and drop it in there. Okay, so now I have all of my code from the instructions, and I put it in here. It's very important that I have the same line breaks as what are listed in the code. It's also important that I punctuate everything just as it is here so that I can make it work. So this is a discrete probability distribution. We want the values of the variable. So what do we have? 0, 1, 2, 3, 4, 5. Well, that's great. 0, 1, 2, 3, 4, 5. Then we need the probability of each x value. 65, 12, 11, 7, 3, and 2. Well, guess what? That's what I've got here too. So yes, I'm working with this problem, and I already did it so that I could demonstrate it to you. But if you had something else, you would have to put it in here. You would have to put commas between the x variables and commas between all the probabilities. And it's important that you have the numbers with the commas, separating them in each of these situations. So inputting the numbers for x, they go in here between the parentheses with commas between them, and the probabilities go in here between the parentheses with the commas between them. Now, this is going to get us the mean, which has, we're just going to use the letter M, it doesn't matter. And then we have the variance and the standard deviation. So I can either just hit this green bar, or I can hit Control-Enter, and it will give me then, as I scroll down, it will give me these three numbers. The first number is M, that's 0.77. Now, if I go back here and I say, what does M talk about? What is the meaning of that word or that number? 0.77 is the average of the number of pairs of dress shoes. So that this survey that we took and we found these different percentages, if we say, what's the average number of dress shoes? It would be 0.77. Now, obviously, nobody has 0.77 dress shoes, but it's the average. A lot of people have 0, but there are people who have more, 1, 2, and so on. So what's the average? 0.77. That's the average of the X values. That's the average of the number of dress shoes. And then we say, what's the variance and the standard deviation? Well, the variance is given to us here, and the standard deviation is given to us here. And we need to round off this answer to 2 decimal places, so that's good. Now, it's important to understand that the standard deviation is not reasonable as what we've talked about with the empirical rule in the past. The meaning of the standard deviation doesn't make very much sense here because 0.77 is the mean, and the 1.26 is how far above and below the mean you would go. Well, you can't have negative dress shoes, okay? So the standard deviation is not very meaningful right here, but it is a number that can be useful, and this is how you find it, okay? So once again, the mean was 0.77. The variance is this number, 1.5771, and then this is the standard deviation, which rounded off becomes 1.26. And those are the answers that we need for this problem.